Hello everybody, welcome back to this wonderful channel called Physics Man. I hope you liked the previous video. If you haven't watched it already, please do watch it. We had done a discussion on JEE mains paper. Okay, now anyway, we'll continue with what we were doing in this series. We are doing NCERT read along of chapter number 1, electric charges and fields. So let's start. So let's do a quick recap of what we have been learning till now. In the first two videos, we have learned about frictional electricity, how charges are produced, positive charge, negative charge, some of the properties of the charges. Now in this video, we're going to learn about unification of electricity and magnetism. Now what is this unification and why is it required? We know that physics is divided into different branches or fields. So it would be, helping us if we could club some of these fields together. For example, first unification came from Sir Isaac Newton. He unified gravity, which led to the understanding that the force responsible for the apple falling on earth and the force responsible for the motion of moon around the earth, or for that matter the motion of earth around the sun, is exactly the same. So you don't have to learn about these two things separately. You can learn about them together under the umbrella of gravity. Another unification we learn is due to Albert Einstein. He unified space and time, and again he unified mass and energy. You might have seen the wonderful equation E is equal to mc square, which is also there on the banner, YouTube banner of mine. So E is equal to mc square. It related mass and energy. Energy could be converted to mass, or mass could be converted to energy. So again, conservation of mass and conservation of energy is out of the window. So yes, E is equal to mc square was a very good unification by Albert Einstein. And again, there is another unification of quantum field theory. It unified quantum mechanics and special theory of relativity. Anyway, we are not going to go here and there. We'll learn about unification of electricity and magnetism. In olden days, electricity and magnetism were treated as separate subjects. Electricity dealt with charges on glass rods, cat's fur, batteries, lightning, etc. We have already learned this in the previous videos. Cat's fur, glass rod and lightning. Batteries we are going to learn about in next chapter, current electricity. While magnetism described interactions of magnets, iron filings, compass needles, etc. Yes, we are going to learn about this in the chapter on magnetism and matter. This is what we have in our mind also. When we think about electricity, we think about light bulbs, AC, all these things working because of current. And again, when we talk about magnetism, we remember the magnet that we used to play with when we were kids, by attracting small pieces of iron filings. But it is a weird thing that these two are actually related. They one produces the other, and the other produces the first one. Now, how this all started in 1820, Danish scientist Ørsted found that a compass needle is deflected by passing an electric current through a wire placed near the needle. So if there is a wire carrying an electric current and a compass needle is placed near it, it deflected. Now it is clear that compass needle is a magnet, and if magnet is deflected without any contact, it's clearly the magnetic force. So electric wire is producing a magnetic force on the magnetic needle. It clearly indicates that the electric wire is producing a magnetic field. So that led to the starting that electricity is linked with magnetism somehow. Ampere and Faraday supported this observation by saying that electric charges in motion produce magnetic fields and moving magnets generate electricity. In chapter on moving charges and magnetism, we learn about Ampere's contribution to the magnetic effect produced by electric current. He gave a wonderful law, Ampere's circuital law, which is a very simple to use tool which will let us find magnetic field strength. And again, Faraday also has a very important contribution which we'll learn in electromagnetic induction. There, Faraday's law states or it gives the equation to find the EMF or the current produced by moving magnets. So magnets moving or the changing magnetic field will produce electricity. The unification was achieved by when the Scottish physicist Maxwell and the Dutch physicist Lorentz put forward a theory where they showed the interdependence of these two subjects. This field is called electromagnetism. Now, Maxwell, he put forward four equations, and Lorentz also put forward an equation. Now, these combined gave birth to a very new field called electromagnetism. So now, electricity and magnetism, you don't have to learn it separately. It can be clubbed together under a single field called electromagnetism. Most of the phenomena occurring around us can be described under electromagnetism. So when we think about electromagnetism, we'll think about charges attracting each other, or the magnetic needle deflecting because of electric current. But no, it can be thought of in everyday life. For example, the friction the friction is also an electromagnetic force. The normal reaction force is also electromagnetic force. The tension force that you have learned in grade 11 is also electromagnetic force. Let's read on. The virtually every force that we can think of, like friction, chemical force between atoms, holding the matter together, and even the forces describing the processes occurring in cells of living organisms, have its origin in electromagnetic force. So it's all due to electromagnetic force because of the particles between them. Electromagnetic force is one of the fundamental forces of the nature. Okay, actually now there are four fundamental forces in nature. One is the very own gravity. So we cannot say that gravity is also electromagnetic force. Actually, there are a lot of work going on to unify gravity and electromagnetic force as well. But for the time being, gravity is a fundamental force. Then electromagnetic force. Then you have weak interaction and then strong interaction. Now, weak interaction and strong interactions are happening in the nuclear level inside the nucleus, but gravity and the electromagnetic forces are long range forces. It can be experienced even at very far distances. Okay, now let's read on. Maxwell put forth four equations that play the same role in in classical electromagnetism as Newton's equations of motion and gravitational law play in mechanics. So we have already learned this in grade 11. We have seen many chapters, and in almost all the chapters, Newton's name came into play, right? So that's why we usually joke if, for example, this many books, this is the contribution, or this is the physics book because apple fell on Newton's head, then what would be the physics book if a coconut had fallen on Newton's head? That would be only this much. Because apple fell on Newton's head, he thought about it and he put forward so many laws that these many books were filled. But if if a coconut had fallen on Newton's head, he would not have thought about it. Now let's continue. So he also argued that light is electromagnetic in nature and its speed can be found by making purely electric and magnetic measurements. He claimed that the science of optics is intimately related to that of electricity and magnetism. You've learned optics in grade 10, and there you learned that light is traveling in straight line, and it can be assumed, or it can be thought of as a line or ray of light, and many such rays of light combine to form beam of light. All these things you have learned, but actually it will be weird when you learn in this grade 12 that light is actually a wave. Okay, and then you will learn that light is not a wave, it is also a particle, and then you will be confused and so on and so forth. We'll get to the confusing parts later. For the time being, you understand that light is a wave. It is actually an electromagnetic wave. There is an electric fluctuation of electric field which produces a fluctuation of magnetic field, and so on. So light as well as other electromagnetic radiations like X-ray, gamma ray, and so on and so forth, they are also electromagnetic waves. Okay, so Maxwell suggested from his four equations, and then there is an equation of Lorentz forces also. So these combined you can study under electromagnetism. So all these things, Maxwell, he put forward the theory that light is a wave, electromagnetic wave, and you can find the speed of light from electric and magnetic consideration, and that you will learn also in later chapter, that C is equal to 1 by root of mu naught into epsilon naught. So if you haven't seen the video I posted in the 2 days ago, JEE Mains paper discussion, this equation was directly asked in JEE Mains. This equation was directly asked in JEE Mains under the units and measurements question. They asked what is the unit, what is the dimension of this 1 by root mu naught epsilon naught. It is clearly velocity, and velocity is meter per second. So with that you could write the dimensions. Okay, anyway, let's continue. He also argued, okay, the science of electricity and magnetism is the foundation of modern technological civilization. Electric power, telecommunication, radio and television, and a wide variety of practical appliances used in daily life are based on the principles of this science. Yes, we cannot think about our life here without electricity. If electric power is there, nothing of these will be there. You won't be watching me. There will be no laptop. There will be no nothing will be there. And telecommunication, radio, television, all these are not possible if electricity or magnetism, the relation between them, these basic principles were not found. Let's continue. Although charged particles in motion exert both electric and magnetic forces, in the frame of reference where all the charges are at rest, the forces are purely electrical. So you can understand this with the thing that charge at rest, it produces electric field around it. We will learn more about this in this chapter. And moving charges, if the charge is moving with uniform speed, it will produce electric field, and apart from that it will also produce magnetic field. That's why the magnetic needle of Ørsted deflected. So moving charges produce magnetic field as well. But if the charge is accelerating, then it will produce electromagnetic wave also. So it will produce electromagnetic wave, which can be in any of these electromagnetic spectrum. Okay, so yes, you know that gravitational force is a long range force. Its effect is felt even when the distance between the interacting particles is very large, because the force decreases inversely as the square of the distance between the interacting particles. You have learned this in grade 9. Okay, I've taught grade 9 also, so I know what you learned in grade 9. In grade 9 you have learned that the gravitational force is equal to F is equal to G m1 m2 divided by r square. So clearly you can see that force is inversely proportional to r square. Force is inversely proportional to r square. Again, in this chapter also you will learn that electric force or electrostatic force is also having such a relation. It is related as like this: F is equal to K Q1 Q2 divided by r square. So again you can say F is inversely proportional to r square. We will learn in this chapter that electric force is also as pervasive and is in fact stronger than the gravitational force by several orders of magnitude. Okay, so we learned that the relation is similar, but electrostatic force is very huge compared to the gravitational force. Come on, but think about it. You have charged particles in you, but you are never attracted to another particle. For example, I have this books. So I'm not attracted to the books. I mean, yeah, I love reading books. That does not mean I have a physical attraction to the book, right? This is also made of charged particles. I am also made of charged particles, but there is no attraction. Okay, that's because we are neutral. The amount of positive charge in me and the amount of negative charges equal. So I'm neutral. This is also neutral. So that's why there is no attraction, because attraction and repulsion are equally balanced. But gravitational force is working. But you don't see me getting attracted to the books due to gravitational force also, because the mass is very less. So you see, Earth attracts us to itself because its mass is huge. But you see, very important thing, I am balancing this book with my fingers. The particles on my fingers and the particles on this book, they are exerting electromagnetic forces. There is an electromagnetic force between them. Okay, now that is balancing the gravitational pull due to Earth. So Earth, being such a huge body, is attracting this book towards itself, but I, being such a puny human being, I am just holding it with my force. So the electrostatic force that I am providing is actually balancing the gravitational force exerted by the earth. So that's why I'm saying electrostatic forces are very, very huge. To be specific, it will be around 10 raised to 36 times huge. That means if I start writing 1 0 0 0, I'll have to fill this entire book, and even still it will cross that many zeros. 10 raised to 36, 36 zeros will be there. So yes, so gravitational force is okay, you have learned it in grade 9, grade 11, very good. But what you're going to learn in this chapter is very huge compared to it. So we'll continue from here in the next class. Okay, before that, you read this one. Refer to chapter 1 of grade 11 physics textbook. Chapter 1 is usually omitted from, I'm sorry, not emitted, omitted by people, because it's already you're going to learn about that in grade 11 and grade 12 in other chapters. So that's why usually in different schools they just omit it. Anyway, we'll continue from here in the next class, in the next video. So until we meet again, it's goodbye from me. Happy physics.